I was very excited to see Stephanie talk about food, right? And that's why I'm here in this mode of cooking, you know? Just some context here. I made a special kitchenette. If you go here on GitHub, you can see what I built over the last few days in preparation for this. And just for context, this isn't my real job, being the Cozy AI Kitchen guy. But I have a friend who runs a video studio nearby, and I had a party, and he said, hey, we have some extra green screen time. Want to use it? So Friday afternoons, once in a while, I'll go see him, and we'll make random episodes. So semantic code's important, but embeddings are even more important. Let's cook with them in the next episode of the Cozy AI Kitchen. So we know about regular computer code, we love it, and when the Cozy AI Kitchen was born, semantic code came into the foreground. Pretty exciting, right? But those of you who have been watching our various props may have noticed the most important canister. It reads long-grade embeddings, vectors just like your grandma used to make. And I made some new recipes. Let's go into my new recipes. So I basically cook up recipes like every episode. It's now 50 episodes. It wasn't a real Microsoft project. I thought it was going to get canceled, but no one knew what to do with it. So it's now 50 episodes strong, and people want to be on it now. But anyways, I was just on vacation in Copenhagen, and I was going through Boston, and I went to the Harvard Coop, that old Harvard institution, the weird department store. I checked if my old book is out there, so just this book took me 6 years to explain AI. It came out in 2019. It was a terrible flop, because people were like, no, this is never going to happen. But it's still durable. And I was looking at the science section. I bought a bunch of books, by the way. I bought machine learning, neurolinguistics, and the reason I'm sharing with you is these books, each of them has a key point here. Intelligence is an emergent property, and tasks such as recognition arise automatically as a result of the propagation of activity over a network of simple processing units. So really, it's an emergent thing, the neural net thing, so we get that. Causal inference. This is a really cool book. It's all about the fact that we think things are always causal, but they're all correlative. But we convince ourselves that, oh, the data says it, but we're just making stuff up. We're also hallucinating. Neurolinguistics book. This one had this great line, infants are capable statistical learners. This allows them to discover meaningful building blocks of language, morphemes and words, initially opaque speech streams. So you see this sort of statistical framing exists in all of the cool stuff, right? Great book called Analog. As a drastic extension of our capacities, writing shaped and transformed our entire environment. So writing is part of our analog human being, it turns out. So if you think of large language models, that's all about semantics. Neuroplasticity. I like this book because it was all about getting older. Those of you are getting older? Anyone getting older here? It turns out when I get older, stuff starts to get bad. Sorry for the young people in the audience. This book, memory, so good. This memory had the killer graph. The horizontal axis is age. If you notice at 50, something bad happens. Everything trends downwards. So, and I say that because when people ask, how can AI help you? It helps me all the time because I've taken 40 years of my work. I've created all the vector embeddings for it. At any given moment, I could ask myself what I thought. And I find that extremely useful in every context. And that augmentation is making close to 60-year-old me much happier. Context is I'm going to do some cooking. And I have a volunteer here. Anu? Where's Anu? Anu? OK, Anu, thank you. Everyone applaud Anu. OK, Anu, come on up. I've created 4 little recipes to get you hungry for dinner. Thank you so much, Anu, for being a part of this experiment. I'm sorry, that's handmade, actually. Where's the microphone go? Microphone went somewhere. A chair right there. Thank you. OK, so Anu, we are AI friends.
We are.
Like, I saw you
We
over
were
there.
geeking out yesterday.
I was like, oh my gosh, she knows so much AI, so good. So one of my favorite analogs, or metaphors, excuse me, is by Herbert Simon. He's an OG of AI, also won the Nobel Prize in business for behavioral economics. And his model in the 60s of intelligence goes like this. The brain is like a pair of scissors. One blade is context. The other blade is cognition. So you need context on cognition to make intelligence. I often like to say, context means like if you're an amnesia person, you don't have memory, but you can produce language. Or you can have the possibility to produce language, but you may have not a clue about how to get a real life in the world, like my younger brother. So you need the two together. So if you can come over here, Anu, we're going to do some cooking here.
John promised me I could run with scissors on
Cooking
stage.
here.
So.
That's AI, I think, safety, right? So there's a context blade and a cognition blade. Here's a sentence. The most challenging aspect of our medical AI project was go ahead and cook with just the cognition blade.
And what is that doing?
Oh, all this is going to do is call an OpenAI completion model, GPT 4.1 mini, and it's going to basically complete the sentence. The most challenging aspect of our medical AI project was ensuring the blah, 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 blah. Now, what's wrong with this? This is called, of course, hallucination.
That's right.
Missing the context.
That's right.
People think it's supposed to sort of it made stuff up.
Yeah, it's supposed to know everything right off the bat. Right?
Yeah, and it's guessing what you're thinking. Like, I had a great, what's going to happen? I mean, it's just going to make it up, because that's the completion blade. That's the model we all know, okay? Now, the problem is that you need to give it context. I am really interested in, and let's say we had this massive conversation. This is the ChatGPT magic. You're talking to it. This goes all the way back to Joseph Weizenbaum, my AI professor in the 80s. If you get all this context, I've been working on a machine learning project, blah, 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 and now use both blades on it.
Okay.
Take the context.
I'm a little scared.
Give it to the completion, yes, yeah. I don't have a cool spinner, so you have to wait for it. Okay. Oh, there it is.
There it is.
And now it's
So
sort of
excited.
on context. See, without context, talking about a concert. Look at this. I'm really interested in the ... And let me add here, did you eat something for breakfast? Did you eat something? Like,
I had that fantastic breakfast where we talked about post-quantum cryptography.
What did you eat, though? That's the most important thing.
Oh, I had eggs.
I had eggs.
It's with me.
Do you like eggs?
I'm a little worried that Sherry knew that.
Do you like eggs?
I do. I love eggs.
Eggs. Okay, all right. So let's add that to the conversation stream here. Now when I ask myself to finish the sentence, when I'm hungry, what happens, Of course, now that's been added to the context. So for some reason, it knows that you like eggs, for instance. Look at that. You love a delicious omelet, so it did embellish. Nice. Thank you, Anu.
Yes.
Thank you so much. Everyone, applause. Oh, and as a gift, this is the failed book, How to Speak Machine, for you. There we go. Okay.
I'm going to write you a glowing review on Amazon so more people buy it.
Thank you so much. Thank you so much. Thank you, Anu. All right. Okay. So we talked about the completion model is everyone's friend. Everyone talks about it. Oh my gosh, inference, so amazing. But the embeddings model, vectors just like your grandma used to make them, so important. So let's talk about embeddings models. Many of the people who started off 3 years ago, the pioneers, with text embedding 8002, who knows what I'm talking about? Text embedding 8002, right, Pioneer, right? So you're using text embedding 8002. What that does is it does this magical thing of being able to play Go Fish. Do you know how you have like a hand of cards and you get clubs or whatever? Go Fish. The embedding model takes, and by the way, this is text embedding 8002, made in December 2022. This is the newer one, text embedding 3 small, which can actually do different things called Matryoshka embeddings. It can actually be more efficient. But what I've done is I've taken Ireland, Irish, O'Connor, and Dublin, these 4 words, and I've generated vectors of 1,536 length. This is text embedding 8002. And that is essentially representing the dimensionality of the semantic space, right? Irish is all these numbers. Oh, I'm a human. I can't do that. But if you speak machine, of course, if you just take these vectors and you use them as, with vector math, you're able to easily produce a scalar. You take the vector times the vector, produce a scalar, so-called cosine similarity, and you get a number that represents the similarity. So those 4 words, Dublin, O'Connor, Ireland, Irish, Dublin, Ireland, Irish, O'Connor, they are proximate. Now in this view, I've reduced dimensionality, but I can show you here. This is Ireland to Irish is 0.919 out of 0 to 1, similar. 3 small says it's 0.668. Irish Dublin says 0.882, 0.567. Why am I showing you this? It's because text embedding into 002 isn't as good as embedding 3 small. And you can tell because what happens with text embedding into 002 is it gives you answers that are very compressed, close to each other. Whereas text embedding 3 actually gives you a wider distribution. So if you look at it, these lines mean 0.7 or more similarity. So this thinks it's actually very similar. Whereas 3 small says, well, actually Dublin and Ireland are more similar than Irish, and O'Connor, it's further away. Okay, so, and why is that important? It's important because the context blade is instant search. It's like for any programmer who is doing search, it's like magical, cheap search. So let's say I have inflation, anxiety, and pressure, and I have roughly 6 documents here. I think of each sentence as a document, and the goal is to figure out which document closely matches inflation, anxiety, and pressure. And what comes out is this is text embedding into 002, thinks this sentence is the closest, this document, whereas embedding 3 says this one is closer. Now notice that it came up with a different hit, basically. Embedding 3 doesn't have biases around certain words like worries, apparently. So that's why you see the difference. But embedding models produce different similarity metrics. And if you're using an old model, please upgrade your embedding model, because your RAG will dramatically improve. Now, those of you who know this word RAG, which I used to hate, because I hate acronyms. But RAG, so-called retrieval augmented generation, is super fun. But the problem is it's not that great out of the box. So those of you who rag all the time, who rag? You rag on friends, right? Exactly. So here I have a document on artificial intelligence research. You see that? Here we go. So the way RAG works is you basically take the text and break it into chunks. By the way, Jerry Liu is here. He's like the goat of RAG, by the way. So if you see him, you gotta touch him, and you'll get better RAG. Okay, so this is breaking the document into, see this is 10-word chunks. I can break them into 25-word chunks, but chunk size matters is what raggers will talk about. It's basically the chunk size, okay? Now, what I'll do is I'll say cutting edge research. So what I'm doing is I'm now going to try to find chunks that match cutting edge research. And so here it's found 3. If I wanted more chunks, let's say I wanted more chunks, I want 5 chunks, it'll find 5 chunks and rank them. If I had bigger chunks, that's another way to sort of cut your chunks, basically. And the goal is to find the similar chunks to be fed into completion. So by just taking that initial query, attaching it to all the chunks, the scissors clip, and it produces a completion that's relevant. So that's the power of RAG. But the problem with RAG, as you can imagine, is that's the difference between knowledge and understanding. Understanding means you've actually tried a little bit versus sort of made things up sort of along the way. So I built this to show what's called graph RAG. And what graph RAG does is it takes a body of text and it tries to create an ontology, basically a graph, to sort of extract the entities and build relationships. And in doing so, of course, what happens is you have a well-formed graph where now you can ask questions that are more specific to the kind of knowledge you've collected. So whether it's like, see the researchers have been pulled out, the type of algorithms, techniques, and so now you can actually query the graph with more understanding instead of just knowledge. Okay, we're going okay so far. All right, last one, my favorite one. Ready for this one? Okay, this is the best one. Okay, because the LLM is so good at getting structure out of unstructured data. If you remember the quantum people are saying like, oh, they can do structured stuff, whatever, they need that. Now the LLM loves unstructured data. So as an example here, this is a letter here. It's like, hey, Sarah, just wanted to update you on my recent move, blah, blah, blah. And I have different examples here. But anyways, I have an extraction goal. Extract the personal and professional information to fill out a contact form. So now, just by giving that query, I'm going to squeeze the sponge. And the LLM will pull out the information in a structured format. And even better for the programmers, it'll create the JSON format so it can be passed on. On top of that, this is just running with 4.1 mini, by the way. And on top of that, any way you'd want to build an access to an API, et cetera, it's just sort of one step or one hop away. So I find that we're hallucinating when we say the word agent. The agent is just a byproduct of the fact that this kind of unstructured to structured data manipulation can happen. And in doing so, it can access real things that computation can access. OK, so that was the 4 recipes. I guess in closing, I just wanted to, and I have 3 minutes left. In closing, I just want to thank Richard for the opportunity to sort of be here. This is a really special place where I forgot that quantum existed. And so I was like, whoa, cool. And then I forgot about blockchain, et cetera, crypto. Wow, it's cool. See, I've been like hiding because I had to find a job in Redmond in 2022 because my parents were in their late 80s. And my sketchy younger brother was really it was messing stuff up. So I was CTO of a physical security company in Boston, and I had to get to Redmond. And my friend said, hey, you want to work on AI? And I worked on AI in the 80s. So I remember the nuclear winter. And I was playing with OpenAI API as like a hobby. And I thought, why not? That's like a sleepy job. I can focus on my parents. 88, not pleasant if you've seen that. So anyways, I joined in October of 2022. And all my friends made fun of me. They were like, oh, I got Microsoft for AI. It's so embarrassing. I said, no, I don't know. I got to get a job, And then I got to touch GPT-4 before it came out. I was like, oh, this is very interesting, but this is not going to whatever, right? And then in November 2022, ChatGPT came out. Suddenly got very busy. So anyways, I've been working in this space since, I guess, the early years. And in this new era, I lead engineering of the way people use the tokens, et cetera, developer-focused experiences. And I'm so glad to have been here because I've learned so much. So 1 minute 30 left. Thank you very much, everybody.